key, and this is an important slide, we readily understood kind of early in the piece that AeroMACS is an international movement. It'll cross borders. PKI secured avionics will actively cross borders. And so we need the buy-in not only of the manufacturing regulators, ANSPs, airports, but we have, fundamentally we need the buy-in of member states, as disparate as Russia, the Russian Federation, the United States, Mexico, Brazil, China, Japan, et cetera. And so we approached ICAO early in the piece, and they have agreed to play a very central role in not only as kind of guiding us in the development of AeroMACS PKI, but also as an authority within our PKI structure. And so we're delighted to report that ICAO is welcome to that role, and indeed they see this model of ICAO playing a central role as an authority within the AeroMACS PKI structure and the WiMAX forum with partners implementing it as perhaps being a model that will extend beyond AeroMACS. And so stay tuned for more on that. And on this slide, you'll see as well that we have consciously leveraged and connected the development of AeroMACS PKI to ATA Spec 42, which was not only appropriate, but necessary. Next slide, please. Okay, so the other kind of remaining, and this will certainly be true, I suspect, in many jurisdictions, but it's absolutely clear in the United States. You can advance the slide there, Rich. There are really two elements to be able to become a licensee of spectrum in the United States. One is the spectrum must be published, which has occurred. The Federal Communications Commission, at the request really of ITU and the FAA and NTIA, has harmonized the spectrum table to the ITU decision and sort of identified the MRS band 5091 to 5150 as described here for AeroMACS. Next slide, please. What needs to occur next is the development of what's called a service rule or a petition. And that really describes who might become a licensee of the spectrum, what are the rules for becoming a licensee, where would the spectrum be used, what are the technical characteristics for equipment operating the spectrum, et cetera, et cetera, et cetera. So the WiMAX Forum has taken the lead with Council WBK in Washington, D.C. To create a draft for this petition. That has been through, I think, 2 or 3 red lines already. We're working very, very closely with the Spectrum Office within FAA. We're also working closely with Airports Council International, the American Association of Airport Executives, ASRI, and others. And it's our intention to work with them. Our goal is to submit, well, really to circulate a draft between the stakeholders that ultimately will want to exploit AeroMACS spectrum, AMRS spectrum, and submit a draft that represents a consensus view. And our goal is to do that this year. The FCC, we have met with the FCC. They are expecting this. So I expect within the month of April to have a new draft, which I think will go a long way towards identifying what the FAA is asking of us. And at that point, it will probably be the next step for me, anyway, in the WiMAX forum, would begin socializing that draft with ASRI, ACI, AAAE, and the other stakeholders. So this is a bit of a stay tuned, but it's a key activity. It's one we have to do. There's nothing preventing an airport, an ANSP, or an airline from utilizing AeroMACS spectrum in the United States on a trial basis, but until we get this service rule adopted, drafted and adopted by the FCC, full commercial kind of unfettered operation will be constrained in the United States. So it's something that we're certainly focused on getting done. Next slide, please. Next slide. So I'll end with what I hope is pretty exciting. We have really been busy, as this slide will attest, and I really have to salute the effort and energy within Eurocontrol, CESAR, and the Federal Aviation Administration. They have been real leaders in pushing the envelope as far as what this technology can do. The FAA has been very aggressive in publishing pretty expansive lists of potential applications for AeroMACS, and they've actually tested that thesis by trialing with pilots, R&D activity, and most recently in cooperation with NASA, looking at airborne access to swim. So the FAA is really pushing forward aggressively to not only think of applications but test them in the real world. We are also busy as a manufacturing and kind of a evangelization community, bringing the promise of AeroMACS to other markets. And so we're delighted to report that China is really moving forward aggressively. Chengdu deployed last year, or 2014 rather. Beijing Capital Airport is supposed to deploy by May of this year, a fairly sizable deployment. Our partners in Europe are deploying, I believe, Rome as well as Milan. We are meeting with the Brazilian authorities in a week. Again, the goal is to deploy either in Campinas or in Rio. We met with the Russians in Moscow a week ago, and there's 2 entities that want to deploy in Moscow. You have a list of U.S. airports that have deployed under the ASSC program, and we certainly expect others. Certainly Brent will speak to the FTI process within FAA, which I think promises to open up AeroMACS to quite a few more U.S. airports, which is very, very exciting. So my goal, and certainly in Japan, JCAB, ENRI, and Hitachi have been leaders with an early deployment in Sendai, which really kind of demonstrated the promise of AeroMACS in a real-world setting and allowed a lot of successor airports to sort of study that effort and learn. So we're very thankful for that. My goal this year is really to end not only with China, Japan, the United States, but to have real systems deployed in either a pre-trial or a pre-commercial environment in Brazil, Russia, certainly support the Beijing Capital Airport deployment, but hopefully as well in the Kingdom of Saudi Arabia as well, where we have a lot of early interest. Next slide, please. So this is, again, sort of for the record, it's not the size of a telecom market, perhaps millions and millions and millions of devices a month, but it is a sizable market to address, as everyone on this call will appreciate. And this is really what we're focused on as far as a manufacturing and airport ANSP airline community. There is no reason, if the business case obtains, why all of these equipment classes would not be enabled really through AeroMACS. And this is so we have an eyes wide open kind of aggressive view of where AeroMACS can go, and we're working very hard with ANSP and airport partners to kind of show that promise. Next slide. So that concludes my remarks. I think Brent Phillips, unless I'm wrong, is kind of next up. Yeah, there we go. And so I'll pass it to you, Brent. Carry it on. Carry away.
Hello? Okay, I think I've just been unmuted, so you can hear me okay. Yes. I'm going to go ahead and move through here fairly quickly. As you mentioned, the FAA is moving out very aggressively in adopting and trying to use the AeroMACS system. And I think you'll see by the first chart the reason why we're doing that. It's basically that the FAA currently uses cable or fiber optics, which they dig up the airport, and that's costly and very inefficient and a disruption to the airports when doing so. So when they were made aware that we could actually utilize a wireless communication system, they saw that as a great advantage to many of the programs that are not only in place, but which will be coming down the line. So if you're familiar, the FAA is moving forward their next generation program. We have periodically in RTCA, the Next Generation Air Traffic Management Committee, the AeroMACS, which addresses basically what their desires are for the FAA to prioritize in the area of next gen. And the number one priority is information sharing on the airport surface. So this actually bodes very well for the AeroMACS system because basically all we have currently in addition to the cable loop is the datacom program, and we foresee that as not being basically designed to accommodate large volumes of information sharing, which we are expecting with the ATS and AOC applications that are coming down the line. Next view graph. So you may be aware that we're focusing on the left-hand side, which is the air traffic support of not only mobile but also fixed assets on the airport surface. But there's also two other customers that are interested in using AeroMACS, and that's the airlines, the airports. And I'll get a little bit into the description of what each is doing through my presentation. Just wanted to point out that the allocation that we're operating in, the 5091 to 5150 megahertz band, is an ITU allocation, which is interpreted on a state-by-state basis to indicate that we can use that for aeronautical use, mobile and fixed aeronautical applications. So we've selected, most likely in the FAA will be using AeroMACS in the near to mid time frame to support our fixed assets on the airport surface. And then as we develop the documentation and get the airlines in line, we'll probably move then to supporting the electronic flight bags, and then ultimately a full implementation of avionics, AeroMACS avionics into the aircraft. So let me go to the next view graph, which gives you an idea, notional idea of some of the applications that we're looking at. The blue lines indicate those that would support where AeroMACS would support FAA's needs with the various radars and surveillance sensor systems on the airport surface. We also have a number of programs, including weather sensors, that would like to be able to select where to place their sensors versus having to locate them close to or in the proximity of the cable loop that's already on the airport surface. So you can see the advantage of an AeroMACS system allowing us to move the various sensors around to their best location as opposed to having to set them right next to the cable loop that's currently there. The green lines indicate what is envisioned to support not only the airlines but also the airports in the U.S. Now, going to the next view graph, as Declan mentioned, the FAA has been looking probably for the last year to 2 years on how we would go about actually acquiring this system. And it was determined that the best approach would most likely be to go through a service provider. Now, that hasn't been completely vetted and agreed to, but they have agreed to move forward with that concept to the point where they will qualify one or two vendors in the next year's time frame. And thus, when they have those two vendors qualified, then any program within the FAA or U.S. program would be able to come in and acquire that service through the existing FTI infrastructure programs. So you've got the FAA telecommunications infrastructure that's already in place and supporting all of our telecommunications needs on the surface. And what we would do, and is currently being offered by the FTI, is to provide a service for the last mile, or in this case, it would be the AeroMACS service on the airport surface. So Harris is in the process. If you go to the next view graph, I'll give you some timelines. We have Harris, who is the prime for the FTI contract. They have developed a proposal in support of an RFP that was released by the FAA back in December. That proposal happens to just be being delivered tomorrow. That proposal will be reviewed by the FAA, and then over the next year we will procure the systems from the one or two vendors. We will then test them at the various test beds that Harris currently has in place, and then we'll qualify those two vendors to be available for selection from the FTI list of opportunities for the wireless capability. Next view graph. So as I mentioned in the bubble chart earlier on, not only is the FAA looking to use AeroMACS, but also we have the airports who have shown a great interest. They have a number of applications that the FAA does not own and operate on the airport surface, which they are responsible for. And they are currently having to do the same method of cable, of trenching the cable, or actually in some cases they're using wireless systems that are not in the safety and regularity of flight band. Thus, they should not be using those wireless systems to support anything that falls within that category. So they recognize the benefits of the AeroMACS system. The first application is actually being investigated for the use in Boston Logan Airport. We've done the measurements in the surveying of that airport for the location of the sensors, and the airport's office here within the FAA is in the process of procuring the prototype systems as we speak. Their plan is then to actually transfer those systems to Boston Logan, who will then maintain and or implement and maintain them over the next year time frame. The reason that they're doing this is because they want to force the non-government entities to begin to go through the FCC process to get the licensing for the non-government usage of AeroMACS. So this will force the issue. Boston will then proceed to receive their licensing through the FCC. They'll test over the next year period of time frame, and then their intention is to go operational after that time frame. There's not currently a waterfall for the airports, but the next one that they're looking at is Dallas-Fort Worth, who's also shown interest in using the AeroMACS. So let's go to the next view graph. So as I mentioned, in addition to the FAA's use of AeroMACS or supporting the various systems, you can see a number of systems there that the airports is also planning to support. And then the next view graph after that is just a pictorial, gives you a better idea of some of the applications and the locations we have. They want to use it for a foreign debris detection system on the airport surface. They have their own weather sensor systems. They need to detect any wildlife, or they want to use it for perimeter surveillance. So there's a number of near-term applications that the airports are currently considering. Next view graph. And then finally, the third bubble of the three was the airlines, and we indicated that they were probably the long pole in the tent as far as getting AeroMACS implemented and used. And as a result, we have recognizing that the standards process is a good 3 to 4 year process in developing those standards. We have initiated through the ARINC AEC committee the beginning development of the form, fit, and function standards for AeroMACS. That group has kicked off and had 2 meetings and they've already have a draft standard in place that is being circulated. As you can see, when we met with the AEC, we've received unanimous approval to move forward with this standards work from the airlines that were participating in the meeting, including American, FedEx, Southwest, United, UPS. Then we had the airframers in there as well. So we have Boeing on board, and we have Airbus. Then we have, of course, the avionics vendors and other interested organizations. So that work is proceeding very efficiently, and we see AeroMACS making its way into the cockpit probably within the next 5 to 10 years. Finally, I think that concludes my presentation. If you want to go to the next slide there, Richard.
Yep, you are at the last slide.
Okay. All right. Well, I appreciate it. Thank you.
Thank you so much, Brent. So next up, we have Nikos Fistas from Eurocontrol.
So hello, everybody. What I will try to give in this presentation is to cover 4 items. So if we go to the next slide, Richard, sorry. So we'll be covering 4 items. I'll give a very quick reminder about the context and the key features of AeroMACS. Then I will briefly describe the stakeholders, and then I will talk about the current development status, and then I will close by highlighting what is the importance of AeroMACS for aviation. So if we go to the next slide and the one after that, so what is important to note is that AeroMACS is part of the wider aviation strategy for the future communication infrastructure, so the future data link. So this is there is one data link specific for the airport surface. This is AeroMACS, and this is complemented by other new data links, more efficient data links for aviation. One is to support en route and TMA, the LDACs also, and also to support the oceanic as well as continental operations to use SATCOM. So this is important to note that AeroMACS is just the first of these new data links that is coming for aviation, and this is going to be an important test case for aviation to support network security, all these new features that will be implemented for the first time by an efficient data link for aviation purposes. Also, if we look on the next slide, what is important to note is that AeroMACS is also part of the global planning. So what you see here in this slide is the ICAO, the International Civil Aviation Organization Global Air Navigation Plan, and there is the communication roadmap. And what you see here, this graph is divided in 2 parts. On the upper part, you see the enablers, the technical enablers, the link media, and the lower part, you see the different services. And what you see in the red rectangles is specific references to AeroMACS and specific services that AeroMACS is going to operate and support in the airport surface. Now, in the next slide, you see the European master plan, which shows the planning in Europe, and also AeroMACS is a recognized element in this master plan. In the next slide, what you see is, sorry, maybe we can go to the next slide, please. So what you see in the next slide is some of the key technical features of AeroMACS. Sorry, maybe there is some delay. So what you see in this slide, you see some of the key benefits of AeroMACS. So what is really there is the provision of high throughput for the airport surface communications. Also, we see AeroMACS providing relief to congested VHF spectrum in the airports. And a very important element is the AeroMACS is able to support worldwide interoperability and also the integrations of the critical communications for the 3 critical stakeholders in the airport environment, the ANSPs, the airlines, and the airport authorities. Also, what we expect for AeroMACS is using synergies and sharing the infrastructure to reduce the overall cost. And AeroMACS will be the first data link to offer some increased security capabilities. And as a result, AeroMACS will be able to reduce the airport congestion and the delays and enhance the situational awareness in the airport surface. There was one slide just before that was talking about some of the technical features of AeroMACS, but that we can get it also on the deck. So indeed, I mean, this is a slide. So you see that this is really a modern 4G technology. But maybe we can go on to the stakeholders, Richard. Sorry, I'm keep confusing you.
No problem. I'm just trying to react. It's all great information, Nikos.
So what I would like to share with you in these things is that what are the key three stakeholders. So you saw also in the slide from Brent the variety of the different applications that AeroMACS can support. So there is really supporting gate operations, ATC, video surveillance, we're having service vehicles, we're having stream, the airlines, and also to support data collection and sharing. And if you click one more time, what you will see here is in terms of bandwidth, what are the capabilities of AeroMACS. There is some delay. Okay. So we're having now these three key stakeholders, the airports, the airlines, and the NSPs. But in terms of usage of the throughput, the available throughput, what you see in the next click is that we expect that the NSPs will be a small part of using this bandwidth, and the airlines and the airport authorities will be the key user of this band. I think you need to click, maybe you're using an older version, so you need to click one more time, a couple of more times. So you see exactly in this slide, so the sharing between the NSPs and the airport and the AOC is the ATM, the NSPs will be using a small part of the pipe available, while we expect the airports and the airlines to be the major user of AeroMACS. Now, if we're going to look on the different cases in the next slide, so what you see here is that if we consider the implementation perspectives, we're having three different perspectives. One would be addressing the airports only to support the airport infrastructure. The other perspective will be to support the airports as well as the airlines. And the third perspective, of course, will be to use the full intent and capabilities of AeroMACS to support airport, airlines, as well as NSPs. And if you click twice, actually reads, what you will see is that there is a number of elements that we need to consider. First of all, on the airport, we only have vehicles that we are implementing, whereas for the other two implementation perspectives, we are having the usage of the aircraft. But what is also very important and common is that in any of these perspectives, we need to consider commonly the network aspect, the security aspects, as well as the sharing of the spectrum among the different users. Now we can move on to the third part of my presentation. So in the next slide, you see the current development status. And there is just the one slide next that is actually talking about the status of the standards. AeroMACS has been one of the data links in aviation that has achieved a standardization status in very short time frame. So we're having currently in ICAO the SARPs that have been approved, which is the global aviation standard. Then we're having the technical manual that it is ongoing and expected to be finalized by June or July this year. I have to remind that the applicability date of the SARPs is November, so November is the date that globally the aviation standard for AeroMACS becomes applicable. Then before reaching the ICAO standards, we had an extensive work in Uruguay and RTCA, so we developed MOPS and MASPs. And we started actually by developing the work in the profile that we've done it together with the WiMAX forum in Uruguay and RTCA. So we selected the features from the WiMAX standard that they are important for interoperability. So this is a set of mandatory features that they need to be implemented by AeroMACS in order to support global interoperability. And the last part of the standardization puzzle is the development, the availability of the avionics standard. And I think Brent already mentioned to you that there is the work ongoing in AWC for the development of the ARINC specification for AeroMACS, and that will conclude the availability of the aviation-specific standards. And that will complement also the work that the WiMAX forum is doing with the different standards and documents relevant to AeroMACS. In order to reach this maturity in terms of standardization, which was very quick in terms of aviation timings, there was really global coordination and coordinated efforts in Europe, in US, and Japan. So there was really a lot of testing. Only in Europe we had 2 CESAR projects that they had the development of prototypes. Also, what we expect is that there will be follow-on activities in Europe in CESAR 2020, and maybe in the future we're expecting to have a demonstration activity involving the different actors. And I mentioned already that we had significant testing activities in the US as well as in Japan. So now, if we move to the next slide. We're entering to the last part of my presentation, and this is just to highlight what are the important elements and to summarize what are the important elements for AeroMACS in relation to the aviation. So one of the key things that we are having now after 4 or 5 years of standardization work is we're really having a globally standardized air interface that is really providing a modern and efficient 4G, 4th generation data link offering high capacity that can support both vehicles and aircraft on the ground and also fixed communications in the airport surface environment. The other key important element for AeroMACS is the operation in regulated spectrum in the 5 GHz band. And this is important because by operating in this protected part of the band, it can claim protection from interference because the allocation for AeroMACS is to support the critical communications for the safety and regularity of flight. Then the other important element for AeroMACS is that it is really supporting ATC, AOC, as well as airport authority communications using a single technology. So it is integrating all the critical communications of the different stakeholders in the airport environment in one technology. And like that, it creates synergies between the different users. And lastly, but not the least, is that AeroMACS is part of the wider future aviation infrastructure, what we call the FCI, as you saw in one of the first slides. So the development and the investment of AeroMACS is something that is going to be reused also for the other data links to come. What we're trying to do is to come with common solutions for security, for network aspects, but they will be applicable also for the other systems to come. So AeroMACS should not be seen as one data link in isolation, but is part of the wider infrastructure in aviation. If we move now to the next slide. So if we would like to examine what are the alternatives for AeroMACS to aviation, if we take, for example, the AOC and the airport authority communications, there do exist various commercial systems, sometimes proprietary, or some other systems that can support just AOC communications. For ATC communications, today we're having only VDL Mode 2 that it is authorized to support ATC communications. We do have some performance issues that we are trying to resolve. But then if we are looking for something that is combining all these 3 types of communications, ATM, AOC, and airport authority communications, there is not any other option that is currently standardized or globally agreed to support these communications. So if you click once, is the conclusion of this is that AeroMACS is really the only globally standardized technology that it is designed to support the 3 stakeholders in the airport environment. And I believe that maybe there is one more slide from my side. So this is just highlighting that there has been some long development for AeroMACS. So you will get also in the backup slides some information, but this is just to highlight that AeroMACS has been developed, has been selected in aviation in 2007. There is a lot of time that aviation has taken to reach the standardization status. There are a number of people that they are raising the issue of the comparison with the LTE and whether LTE could be a suitable media. What I want to highlight here is that it may be misleading to compare AeroMACS with LTE because LTE is not authorized to support today safety critical communications. And by the time it takes to develop the standardization, the commercial world is moving very fastly, and we cannot really, in aviation, we cannot always catch up. So the idea of maybe customization or maybe trying to find, to stick to the protocol for aviation is an important element to provide the required stability for aviation, especially for the safety critical communications. And I think this is the last slide from my side, Declan.
Thanks very much, Nikos. So next up we have Brian Crow, who is the Vice Chair of our Aviation Working Group and also represents Hitachi. Before we start there, I just want to let folks know we are running a little behind, but we do have the ability to run over on this webinar, so we'll certainly take some time to field some questions. If you have to drop at the hour and we don't get to a question that you may want to answer, make sure and shoot us an email, and we'll get the right person to provide an answer or clarification for you. So with that, I will turn it over to Brian.
Thank you, Rich. It's good to talk to so many people on a webinar like this, and as the last person up, I'm kind of the master of the clock, but I'm mindful of the fact that we'd like to leave time for questions when I finish. So I'm here to talk about two topics in particular. These topics were introduced by Declan, and I'm going to take a deeper dive on these topics in the time that is allowed here. We're going to talk about certification, and we're going to talk about PKI, and I want to give everybody on the webinar some insight and detail to the progress we've made so far and what our future activities will be. So let's go to the next slide, please. So in the certification realm, I'd like to first of all recap what our objectives are. Interoperability, assured interoperability is the overriding objective that we have in front of us. And to achieve that objective, we have a set of requirements that come to us from the SARPs and the MOPs. And these requirements are really a feature subset of WiMAX that are directly applicable to AeroMACS and the services that AeroMACS provides. On the WiMAX form side of the equation, we have a suite of test procedures that have been defined to support certification of WiMAX networks in the past, and we draw on this suite of test procedures to match them up with the subset of functional requirements that come from the SARPs and MOPs to create testable requirements for our certification laboratory. And Eugene Crozier at PowerTech has done the heavy lifting for us. He represents the certification lab that is engaged with AeroMACS presently. And we have a triad of documents to produce. The first document is called the Radio Conformance Test document, and this document has been completed in our WiMAX Forum working group, Aviation Working Group. You see it's noted here with a document number. All our documents are numbered, so they can be referred to and referenced. The radio conformance test is a one-sided test. It doesn't complete a link between a base station and a subscriber station, but it tests on the radio media the behavior and performance of the base station and of the subscriber station. What I wanted to do very quickly, and we're going to rush through a few of these slides, is to give you a list of the tests that were actually completed and performing for the radio conformance part of certification. And we do these tests, as I said, for the base station, and we do them also for the mobile station or subscriber station. And here in front of us, at the bottom of the slide, you see a list of the tests that are designated for testing the base station receiver. So we have very typical things that you might expect. Receiver sensitivity, maximum input signal level are probably the two most apparent kind of receiver attributes that you might test for. But we do test as well for some WiMAX features, and you see those in the first three tests above. So these are the tests we have designated for base station receiver testing for radio conformance tests. So let's go to the next slide, please. And I'm going to run through these very quickly. Here's the transmitter side of the base station. And then we have some other miscellaneous tests which impact both transmitter and receiver systems. On the transmitter side, you see things like spectral flatness. You see constellation tests. You see some modulation and coding scheme tests. And for the tests on both subsystems, you see things like synchronization and switching characteristics. So this battery of tests for the base station is a one-sided test that is focused on the RF layer, the media layer of the protocol interface. So let's go to the next slide, please. In the next slide here, we have the mobile station receiver test. It's a similar kind of array of tests. Mobile station or subscriber station, it wouldn't matter, but these are the tests for the CPU unit that would be deployed in a car or cart or an aircraft. So let's go to the next slide. The next slide rounds out the tests that we are performing, the RCT battery of tests for the mobile station. And you can see that there is some similarity between the mobile station and base station tests, but there are also some uniqueness because these subsystems have different roles in the network. So let's go to the next slide, please. So we have some work in front of us. We have the other two documents to complete. These documents are called the Protocol Conformance Test Suite, or PCT. It's our current activity in the Aviation Working Group. The PCT document, we believe, will encompass more than 100 tests. One estimate we arrived at was 110 tests, and these tests are pulled from existing tests, but that have been previously designed for WiMAX form certification, but they've been very specifically matched up to coincide with the AeroMACS requirements in the MOPS and the SARPs. When the PCT test is finished, we move on to the interoperability test. The interoperability test suite, we believe, accounts for about 80 tests or so, and we are engaged presently in the PCT with an eye to what the IoT document will pertain and contain as far as the balance of the tests that we have. When we're finished with these three documents, we'll have a complete test suite for certification in front of us in the test lab and for every vendor to execute. So this is a snapshot of certification. Let's move forward the next slide, please. So AeroMACS Security, I want to be very clear here, PKI is one component of a suite of security features. It's the one that has to be interoperable among the most systems, and it's the key feature for authentication and authorization for services. But it's just one of a long list of security features that make AeroMACS a very robust and secure service. Next slide, please. So in PKI, we have a single trust anchor. We have a certificate authority, or a CA. The root CA has stored in it a list of all the certificates that have been authorized by all the device manufacturers and aircraft manufacturers. And every device in the network knows the certificate for the certificate authority. And this knowledge is carefully managed, and it's restricted, and it's because of the unique associations in the knowledge in every device that one device can be authenticated securely and confidently. So the root CA is known among all the devices, and we really have a circle of trust, but the real trust anchor is the root certificate authority. Let's go to the next slide, please. So Declan put forward a lot of status that is done. We've done an awful lot of work. And here you see that we're really engaged with ICAO to establish the role of the root certificate authority and actually negotiate the roles of the various organizations that participate. We have some things complete. We have a PKI certificate profile complete, and we have a policy draft that is technically complete, but we're socializing the draft among a number of organizations to encourage feedback and incorporate feedback so that everybody's needs are served. and we can move forward and socialize the document as a whole and have it accepted by the community. Let's go to the next slide, please. Our PKI document has a document number. I want to reinforce the fact that it is a draft document at this point in time. It's not working group approved or WiMAX form approved at this point. But here is a table of contents for this document. You can gauge the scope of the document here just briefly in this one slide. But we treat the whole scope of policy and certificate specification in this document, including the life cycle of the certificates and the management of those certificates. Let's go to the next slide, please. That is the last slide, okay. So I appreciate everybody's time to listen, and I encourage people to ask questions either in the forum here or offline as they would like. Thank you.
Thanks very much, Brian. So, yeah, I recognize that we've run over. I don't have really any questions coming from the group, and typically a lot of folks take a little time to absorb and ask questions after the fact, and that's fine too. We're here to address those at any time if you guys want to email us. I'll ask if, you know, certainly I can field some questions from or for folks or to the panelists, but again, that we've run over, maybe I can defer back to Declan to see if you want to continue the time or if you want to close.
Yeah, I think, Rich, thanks for that. I think we're at an hour 5, so we could kind of wrap it up. But what I might suggest, Rich, is that we develop an FAQ and email it to all the registered participants of questions that have come in. I know that there's been a few that have come in already that are good and on point, and there undoubtedly will be others. But I think that might be a suggestion, that we then try to distribute that sort of coincident with the recording and the presentation when they'll be available. But I think it's been a comprehensive presentation. Our goal had been, from a U.S., European, and other standpoint, to sort of brief to the community what we're trying to do as far as certification, security, deployments, what's happening in the European space, what the FAA is doing, which is pretty exciting. And so I want to thank all the panelists. And I think we could probably wrap. There may be a question. I think there's a question coming in. I can't really see it, from Edgar. I don't know if you see that, Rich.
I cannot.
Okay. Well, let's try to capture that, and then, as I suggest, in an FAQ. I want to defer to Alok as the chair of the Aviation Working Group. Are there any final comments you want to make before we wrap up?
Yes, there is a question. It says, FAA, AIP eligibility for airports for this equipment design engineering besides Boston, any other airports interested in participating in test bed?
Can you take that, Brent? Brent, I think you're muted.
Oh, okay, I'm sorry. Yeah, as I mentioned during the presentation, Dallas-Fort Worth has shown interest in obtaining the AeroMACS system, and I believe the airport's office here in the FAA will be looking into 1 year from the time that they implement at Boston to consider moving another network over to Dallas-Fort Worth. So I'm not sure if that's the particular question. If there's other airports that would like to get involved, if that's where Dan's coming from, please contact me, and I'll put you in touch with Naeem Hoke, who is our airports representative here at the FAA, who is leading the effort to make sure AeroMACS gets implemented at some of the test airports.
And I guess I would just add to that, this is Declan, that we work pretty closely with the Airport Council International of North America, as well as world and European arms. And I think Brent has correctly characterized that the FAA Airports Office has an interest in supporting airports' adoption of AeroMACS, but there's nothing to prevent an airport in and of itself, testing and or adopting the technology, and you can be directly in contact with the WiMAX forum for more information on spectrum licensing, manufacturer matchup, all that. Okay, so let's wrap it at that point. Alok, I'm not sure if you want to say any final comments, Alok, before we close.
Yeah, sure. Thank you, Declan. Thanks, Rich. I'm really excited with the participation on this webinar, the extent of the people, and also the geographic regions and organization that joined this webinar that demonstrates how interested people are on AeroMAX. I think what you have heard from all the presentations today, that AeroMAX is ready in terms of its capabilities and standardization to go prime time to support safety services, combining air traffic communications, airport authority communication, as well as airline communication. So a lot of trials and a lot of planning in place. 2016 is going to be a very big year for AeroMAX to take it from standards and trials through maybe initial operations. So that's what I'm hearing from different parts of the world. Now, going back to the other question I had, was posed. Other than DFW, there is also some interest from airlines that potentially we might be looking at Atlanta as well as one of the U.S. deployment. So anyways, I think just to conclude, Declan, I think for everybody's benefit, this is certainly one of the technologies that can bring things together for all of the aviation stakeholders, and it's ready for implementation.
Great. Thanks, Alok. And so we will be, as an aviation working group, in a WiMAX forum at ICNS in the latter half of April in Washington, D.C. And so if any of you are D.C.-based, delighted to see you there. And be in touch with us. We're a member-driven activity, so if anything you've seen has really piqued your interest, be in touch with us on how you can get more involved. But with that, I'd like to thank all the panelists, and thanks to Alessandra and Sophia, who really have pulled this together on our team, and Rich as our host. With that, we'll close. Thank you very much. Bye-bye, everybody.
Thanks very much, Declan. And just a reminder to folks on the screen, you see Sophia's email address. If you have additional questions, feel free to email her. And as a reminder, you'll see a press release and a presentation distribution on Monday the 4th, and we'll consolidate all of this and provide it to all of the participants. And in the meantime, if you have any questions, please email us. And thanks again, everyone, for your participation.
Bye-bye.